Hello, everyone. My name is Craig Taub. So before I start, just a little bit about me. I'm a software engineer at Nested. We are an estate agent who help you sell your property chain-free. So if anyone is interested, come and chat to me after this, or alternatively, look us up online. I'm a member of the Mocha core team, so I'm very passionate about testing. I'm a big football fan, mainly QPR, and you can catch me on Twitter, GitHub, and Medium. So today, we are going to be focusing on 100% client-side, just querying, so no mutations, batching, subscriptions, or any kind of complicated memory or caching strategies. So it's kind of just the basics of what you get out of the box. This actually came from my own interest in how Apollo actually works under the hood with what I was using it for. So how easy is it to replicate what they've already done? How does it actually do it? So before we get any deeper, just a look at the Apollo organization GitHub architecture. This is just for the components that we're going to be talking about today. So they're split into repositories and mono-repositories. There's about 130, and as you're going to notice today, it's really largely written in TypeScript. So before we get too deep into Apollo, one thing we need to touch on first, and I'm going to apologize now, this might get technical. I know it's like quite late, hopefully be okay. So if anyone is not familiar with observables, they are a new asynchronous primitive. They can help us solve problems that promises and streams just can't help us solve. They do this because they have some powerful properties. They can be run in a sequence multiple times, they can be lazy, cancelable, and they've got some operators built in to help us actually manipulate data. So let's look at an example. So here we're going to create our observable, or number one. So we've created a subscription function, and then we're going to instantiate our observable for ourselves. The second thing is we're going to now subscribe to that observable, and on subscribing, we're going to be invoking our subscription function. So what's actually happening is we're defining a one-to-many relationship between objects, where a state change in the parent is going to fire an update to all of the children, all of the dependents. For the JavaScript, it's in stage one of its proposal, so hopefully it's coming fairly soon. And if anyone is interested in making use of it as it is, I'd recommend the Zen Observables library. It stays very closely to the spec and is actually what Apollo themselves use, so it comes very well recommended. Right, so what are we actually going to be doing today? So here's a kind of breakdown of your basic Hello World kind of query component that you might find on the website. We've got our setup, hopefully you can see this, our setup on the left, and then our main component on the right, where we're just doing a query and rendering some data. So this is what we're going to be breaking down today. We're going to break it down to its core components. So let's make a start. So the in-memory cache, it's an ES6 class. It's extending Apollo cache. The default takes the form of something called an object cache. And that's what we're going to be using as we're using the out-of-the-box setup. So the object cache is an ES6 class store with setters and getters, and there's an instance property for data. Moving on. So the HTTP link, this is the transport layer adapter for HTTP. It requires that the fetch API is actually already present in the runtime environment. So what that means is that they don't provide any polyfilling or any built-in mechanism to provide the fetch API. You can hand it via an option, but they won't do any of it for you. As you can kind of see from the screenshot here, we're returning an observable, and this is going to require a subscriber. And the fetch is actually executed inside of the observable subscription function. So that fetcher method, internally, it's calling the fetch API. So on trigger, we're going to execute the fetch and then run the next in the sequence with the response. As you can see, the result, after we've made our fetch, is handed into the next for that sequence. And that's how the response is fired back to the children. So onto the Apollo client. This is the bridge between the HTTP request and the actual component that's going to render the data. It's an ES6 class. Its job is to send the query in the form of a GraphQL document, receive the results, and cache them in the store. Its primary purpose is to make the observable from the HTTP link on the previous slide available to clients for subscriptions. When the observable is triggered, the data is normalized and placed into the cache and then loaded into the store. The observable is updated when the store changes. onto the Apollo provider, it actually provides some very thin functionality. It is a React class component. It takes the instance of the client that we've just created, and using the React context, it will provide that instance to all the dependent children. So all of the children, all of the descendants will now have access to the client via this.context.client. Onto the GraphQL tag. Its job is to get the query ready for processing on a real GraphQL server. That could be Node, that could be anything. Uses the official JavaScript GraphQL implementation repository, that's a mouthful, for language parsing. So we can see here, it takes an ES 2015 template literal string in, processes it, and then outputs a GraphQL syntax tree object. So now, this is in the correct format to be sent to a GraphQL server for processing. Okay, onto the query component. This is quite a meaty bit of the functionality. It's a React class component. At initialization, it's going to get the client from the context, it's going to get the variables and the query within the component, and it's going to hand them to the client within options. It's then going to get an observable back to use. So we can see from the top screenshot, we've now got a query observable property. Within the component mount, we're going to be subscribing to this observable. As we can see, we call the query observable.subscribe, and we define the next behavior. So what this means is that when the HTTP link triggers the next in the sequence, it's going to force a re-render. And the actual re-render itself is called by the update current data, which is just doing a force render. The last thing is the render itself. It renders children with the query results. So we can see it's following the render prop pattern with this.props.children, and it gets the results on the current observable. So the get query result function is actually just getting the data that's on the current observable. So I know that's quite a lot to kind of take in. So here's kind of quite a high level view of actually what's going on. So we've created our HTTP link, our cache, and our client instance. At the initialization point, we've loaded the observable. At the first render, we're rendering without any data yet. At the mount point, we now subscribe to the observable. At this point, we make our fetch HTTP call with our GraphQL syntax tree object, which has already been processed. Within the response, we call the next sequence in the observable, which then goes back to the query component and then forces a final re-render of the component with data. So I know there's quite a lot kind of going on in there. So in summary of that whole kind of process, the data is all via the fetch API, observables, and it's all comes from being triggered on mount. The rendering follows the render prop pattern, and there's a re-render via React's force render method, which just does a force render regardless of state. The GraphQL client is shared to all children via the React context provider. The GraphQL syntax tree is the official JavaScript language parser. And in this instance, the caching and memory store is a typed ES6 class with setters and getters. And the language is TypeScript. So thank you for listening. Are there any questions?